Lesson 3.5, page number 203. Name of the section is called Addition and Subtraction of Fractions. We're going to start out with some real basic fractions. A couple things that I want to review with you real quick is just what happens when you're adding fractions. Actually what we're doing is we're taking a total amount that we have. So for instance, divide this pie into 8 pieces. The 8 is how many pieces it's divided into. The 3 is how many of those pieces we want to take out. So we want to take out 3. So that's 3/8. And we want to add another 8. We want to take out another 8. So another 8 would be this many. So when all is said and done, we just added together 3 of those 8s plus another one, which gives us 1, 2, 3, 4 of those 8s. Alright, notice what happened here. Our 8s didn't change. The bottom number, the denominator, did not change its value at all. All we did in addition was added the numerators. So let's put an extra step in here because there's something I want to make you aware of. Actually what we did is we put the fraction together to look like that. And then the final step would be 3 plus 1 is 4 over 8. So 3/8 plus 1/8 equals 4/8. Now what we did earlier, remember when we were reducing in one of the other sections? If these numbers are possible to be reduced, then we need to do that. So we write them out again as product of primes, 4 over 8, and we start dividing out the numbers that are common. There's nothing on top, and remember, if there's nothing there, there's a 1, and we bring this 2 over, and now it's reduced to 1/2. You do the exact same thing with subtraction. If I had 3/8 minus 1/8, that's the same as 3 minus 1 over 8, which gives me 2 over 8. And again, I'm going to find the product of primes. 2, can't do anything with that, but my 8 is 2 times 2 times 2. Those disappear, and that leaves me with 1 over 4. 2 times 2. So 3/8 plus 1/8 is 1/2. 3/8 minus the 1/8 is 1/4. So, not much different with than addition and subtraction, except you subtract the numerators instead of add them. Let's look at something like 9 over x minus 3 over x. Okay, same thing. We can rewrite this again. Doesn't matter if that's an x or if it's a number or what it is. Rules still apply. 9 minus 3 over x. And 9 minus 3 is 6 over x. Well, that can't reduce because we don't know what x is. X can be any number at all. We just don't know what it is, so we can't reduce it if we don't know what number it is. So that's where we end up stopping. If we have many, many numbers lined up, well, let's just do 3. Let's do that. It means we take 3 plus 2 plus 9, and it's all over 7. We add those together, and we get 3 plus 2 is 5, plus 9 is 14, and that is over 7. And we'll be reducing those later, but if you look at 14 over 7, that actually reduces to 2, because there are 2 7s in 14. But we'll get to that part later. So, that's all there is to addition. But notice when we were doing this addition, what did you notice was common on every one of these numbers? The bottom number was the same. That's the only way you can add, the only way you can subtract, is if the bottom number, the denominator, is the same number. Therefore, if you're given some problems where that bottom number is not the same number, if they're not common, then you have to do some things in order to make that the case. But before we go to that, let me put one more up here. 8 plus 5 over 8 minus 3/8. Alright, so according to what we did before, we put the 8 on the bottom, and we put all of this together. A plus 5, and this was a minus sign here, minus 3. So we do what we can, which is that, and we are done. We can't do anything else. What happens is if we have a plus or a minus sign between two numbers, that's kind of like a chain or a link that holds those together. So this is not an A and a 2. It's an A plus 2. And because it's an A plus 2, we can't just pull the 2 away and cross it out with 2 times 2 times 2, and cross it out with one of these. Because it's a plus sign, or if there's a minus sign, they're linked together with whatever they're attached to, and you can't separate them. So that's why we didn't cancel there. Alright, well, let's move along, and let's look at some that do not have the bottom number the same, a common denominator. Let's say, for example, we want to find the common denominator, or the 5 over 12 and 7 over 18. What we're looking for, so the book calls it the LCD. They call that the least common denominator. And the least common denominator is, what is the smallest number that 12 and 18 will go into? Now I know just off the top of my head that that number is 36. 12 goes into 36 3 times, 18 goes into it twice. So 18 goes into it twice, and that's an even. I mean, it goes into it evenly. It's not giving me a decimal or a fraction. Like 2 goes into 5 2.5 times, not like that. 18 goes into 36 2, 12 goes into 36 3 times. So it goes into it evenly. So, and they both go into it. So this is the smallest number that both 18 and 12 go into. 24. 12 goes into 24. Problem is 18 doesn't. 18 goes into itself, but 12 doesn't go into it. So you have to find a number that both of these will go evenly into, and it has to be the smallest number. So I'm going to teach you a little trick on how to determine what that LCD is, that lowest common denominator, or least common denominator. So what I do is I take the denominator for both of them, put a little equal sign here, and I write out the prime factors. 2 times 2 times 3, and 2 times 3 times 3. Okay, so these are my prime factors for each one of those numbers. And what I'm going to do now is I'm going to look at the top row and look at the bottom row and look and see what I've got. And I'm going to circle the group of numbers that I have the most of. So if you look at the 12, the 2 times 2 times 3, I have 2 2's here, but I only have 1 here. So I don't want that one. And I look here, I've got 1 3 here, but down here I have 2. So I want those, but I don't want that one because it only occurs once. Now what I do is I multiply these two groups of numbers together. 2 times 2 is 4, times 3 is 12, times 3 is 36. And that is my least common denominator. Alright, we'll do a few more of those. Get the hang of it for you. So let's say that I've got a number like 15 and 10. Alright, I write those as my prime factors. Okay. 3 shows up once here, none here. So the most here. It shows up, 2 shows up once here, but not up here. So I want that one. My 5 shows up in both of them. So it doesn't matter, I want one of them. Not both of them, just one of them. So I just circle 1, and I multiply 3 times 5 times 2, which is 15 times 2 is 30, which means 15 and 10 both go in there. So I'm going to go ahead and turn off the video, get ready for 3.5b, which will be the next one. We'll go over some more.